So once we figured out how to calculate the volume of some simple shapes, we're going to take a look at some applications of those. So we're going to go through some word problems, and some of them will include a diagram and others will not. So a rectangular aquarium has dimensions of 120 centimeters by 45 centimeters by 60 centimeters. So I'm going to start by drawing my aquarium. So there it is. Has dimensions of 120 centimeters. Obviously my diagram is not to scale, but that's okay, by 45 centimeters by 60 centimeters. So I want to figure out how much water is needed to fill the aquarium 95% full. So first of all, I'm going to calculate the volume if I was to fill this entirely up with water. So the volume of a rectangular prism is length times width times height. And it doesn't necessarily matter which one you label as length and width. I'm going to make my 120 my length, my 45 as my width, and my 60 as my height. So I have 120 times 45 times 60. I'm going to multiply these all together. So 120 times 45 times 60 gives me a value of 324,000, and my units are centimeters cubed. Now I only want 95%, so I'm going to calculate 95% of 324,000. So you may remember doing questions like this in Unit 1, so at the very beginning of our course. So in order to calculate 95% of 324,000, I need to convert my percentage into a decimal. So that becomes 0.95. So I'm dividing by 100 to get my 0.95. My of is multiplication, and I'm writing my 324,000. So now I'm doing 0.95 times 324,000 gives me an answer of 307,800, and my units are centimeters cubed. So because it's a word problem, I need a therefore statement. Therefore, you would need 307,800 centimeters cubed of water to fill the aquarium 95%. The next question involves a can of paint. So a can of paint is a cylinder. It has a diameter of 10.4 centimeters and a height of 12.5 centimeters. So because my diameter is 10.4, the radius is half of that, so the radius is 5.2 centimeters. So the next part of the question says, if you require 6 cans to paint the living room, how many milliliters of paint will be needed? So the first thing we want to do is figure out the volume of paint that's inside one can. And we're going to assume that the can is completely full, that there's no air gap in the top. So the volume of a cylinder is pi r squared times h. Substituting in my values, 3.14 times 5.2 squared times 12.5. I need to do my exponent first. 5.2 squared is 27.04 times 12.5. Next thing I want to do is multiply all of these numbers together. 3.14 times 27.04 times 12.5 gives us 1,000 61.32, or I could round this up to 0.3 if I wanted to. I'm going to keep 2 decimal places for now, and that units are centimeters cubed. Now I need 6 cans, so this was the volume for 1 can. So I want to take my volume of 1061.32 and I want to multiply it by 6 to get me the volume for 6 cans. So that is 6,367.92, and my units are centimeters cubed. Now it's asking me milliliters of paint needed. So I calculated the volume of this can in centimeters cubed. But now I want to know how much of this converts to milliliters. So my conversion says that 1 centimeters cubed is the same as 1 milliliter. And so all I would need to do is to convert this into milliliters. So if centimeters cubed is the same as milliliters, then this would be the same as 6,367 decimal, I'm going to keep 1 decimal place, 9 milliliters. Now you'll notice the question, the answer to the question is slightly different than the answer that I have. That's because the original answer used all of the decimal places for pi, so I used the pi button instead of just 3.14. So if you notice that your questions are slightly off from the answers that are given to you on the worksheets, please know that that could be the answer, the reason why. So as long as you are close, then that's okay. So the last thing I need is a therefore statement. So therefore, you would need 6,367.9 milliliters of paint for the living room. Example number 3, a cone-shaped funnel. So we're going to start by drawing the shape of a cone. A cone-shaped funnel has a radius of 5.7 centimeters, and it has a vertical height of 4.3 centimeters. How much liquid can the funnel hold? So we're going to use that same conversion factor of 1 milliliters is equal to 1.1 centimeters cubed. This time we're going to use the pi button on our calculators. So the volume of a cone is pi r squared times height divided by 3. So in order to use the pi button, I'm going to keep my pi into the very last step of this equation. So I'm going to have pi, my radius is 5.7 squared, and my height is 4.3. I'm dividing this by 3. Still keeping my pi, and now I want to do 5.7 squared, which gives us 32.49 times 43, or 4.3, sorry, divide by 3. I want to simplify the last 2 numbers in my numerator by multiplying them together. So I have pi times 32.49 times 4.3. That gives me 139.707. I'm going to divide this by 3. So my next step is to divide the number in my numerator by my denominator. So 139.707 divided by 3 gives us 46.569. And now you're going to use the pi button on your calculator. So now we're going to take that 46.569 and we're going to multiply it by our pi. So sometimes you have a pi button and sometimes it's a little symbol above one of your other buttons. So depending on your calculator, you're going to do that. And then you're going to get a final answer of 146.3 if I only keep one decimal place. My original units are centimeters cubed, but I know that 146.3 centimeters cubed is the same as 146.3 milliliters. So then my therefore statement will be, therefore, the funnel can hold 146.3 milliliters of liquid. So this was just a different version of using the pi. So you can either use the 3.14, knowing that your answer might be slightly different than the answer given on the sheet, or you can solve as much as you can until the very end and then use that pi button on your calculator to give your answer there. So I wanted to show you both examples or both versions of how you can solve when you have pi in your calculation, because either one of those are sufficient. The next example, example number 4, says what volume of wood chips would be required to fill a 2-meter square base pyramid with a height of 1.2 meters. So I'm going to start by drawing my pyramid. It's a square base pyramid. It has a square base of 2 meters by 2 meters, and it has a vertical height of 1.2 meters. So I want to find out the volume of this shape. So the volume of a square base pyramid is base squared times height divided by 3. The base is 2, so 2 squared times my height of 1.2 divided by 3. 2 squared is 4 times 1.2 divided by 3. Simplify your numerator. 4 times 1.2 is 4.8 divided by 3 is 1.6. My units are meters cubed. So therefore, the volume of wood chips needed is 1.6 meters cubed. And you could put fill the square base pyramid, but this is fine. And the last example we're going to look at, Mr. Lodofair is planning on buying 21 balloons for his girlfriend's 21st birthday surprise. The balloons will expand to a diameter of 30 centimeters. So a balloon is a sphere. It has a diameter of 30 centimeters. We want to know how much helium will be required to fill all of the balloons. So we're going to calculate the volume of one balloon first and then multiply that answer by 21. So the volume of a sphere is 4 pi r cubed divided by 3. Now we know the diameter of a balloon is 30 centimeters, so the radius is half of 30, or 30 divided by 2, which is 15 centimeters. So the r of 15 is going to be where we're going to use in our formula. So substituting in the values, 4, and I'm going to keep my pi again to the very ends so you have more practice with that. So 4 pi, and then I'm going to do 15 to the exponent 3 divided by 3. So do my exponents first. So I have 4 pi times 3,375 divided by 3. Now I can multiply the 4 by the 3,375. That gives us 13,500. I'm going to put my pi at the end. divided by 3. So the next thing I want to do is I want to divide my numbers. So 13,500 divided by 3 gives us 4,500 times pi. So now this is where we can use our pi button. So 4,500 times pi gives us 14,137, and I'm going to do 0.2 because that rounds up to the 1 decimal place. My units are centimeters cubed. So this is the volume of one balloon. I need 21 of these balloons. So I'm going to take my answer for the volume and I'm going to multiply it by 21. So 21 times 14,137.2 gives me 296,881.2, and my units are centimeters cubed. So again, you'll notice this answer is slightly different than the one that's given on the sheet. So if you use 3.14 instead of the pi button, you would get an answer that would be much closer to the one that's on the sheet. So know that as long as you are close, then that's okay. So then the next one is the last thing we need to do for this part is to write our therefore statement. So therefore, he would need 296,881.2 centimeters cubed of helium to fill the balloons, or to fill 21 balloons. So the next thing we want to do is we want to think about part B. So part B says to transport the balloons, he would like to put them in a box, which is going to be a rectangular prism. So I'm going to start by drawing a rectangular prism. And so we want to design the smallest possible box that will hold the inflated balloons. So we have 21 balloons. So we need to think about how we can space out 21 balloons. Remember, this is a three-dimensional box, so we can spread out our balloons and we can stack them up if we want to as well. So we could either do it so that it's only one balloon and so really have a really long, narrow box, or we could stack the balloons on top of each other to have more of a square or type box. It won't be completely square. So you want to think about how you want to do this. You'll notice there's no dimensions obtained or no dimensions in this question, because how you stack your balloons might be different than how someone else might stack their balloons. So I want 21 balloons, so I might do it so that I have I might build a box that would fit 24 balloons. That might be an option for me. So I'm going to start by stacking my balloons. So remember, I want 21 balloons. So I might put 3 balloons along the bottom. I might put 2 rows along the bottom. So then I have a 2 by 6, and then I might stack them 4 high. That could be an option. So I want to think about how many balloons I want along the bottom, and then how many balloons I want stacked on top of that. So the base of my square and my base of my box might be 2 by 6, right? So the area 2 by 3. So I could fit 6 balloons down here. Or I might want to put 3 rows of balloons, right? So maybe I want more of a square base. So I have 3 balloons by 3 balloons. That could be an option as well. So 3 times 3 gives me 9. Now I want 21 balloons. So what could I multiply 9 by? Well, if I multiply it by 2, that only gives me 18, so that's not high enough. So I would have to multiply it by 3 because that would give me enough balloon, like the height to give me enough balloons. So I might do this 3 balloons by 3 balloons high. All right, so it's more of a cube shape then. So it's 3 high, 3 wide, and 3 long. Okay, so that could be an option. So the volume of my box could be 3 times 3 times 3, which would give me 27. So I would fit 3 balloons that way. Okay, so that could be an option. Now I also want to think about what the dimensions of my balloons were too, right? So if I'm fitting 3 balloons and each balloon is worth 30 centimeters, instead of doing 3 now, I might want to think about what my units are. So 30 plus 30 plus 30 gives me 90. So now my units would be 90 centimeters. So if I had 3 balloons, so I know my box will hold 27 balloons, but I only need 21 balloons. So my box is going to be big enough. So now I need to think about dimensions. So if I stick them in so that there is no wiggle room because I don't want my balloons to float away, then the width and my dimensions would be 90 centimeters by 90 centimeters by 90 centimeters. And so now let's calculate the volume of my balloon, of my box, using centimeters now. So 90 times 90 times 90 would give me 729,000 centimeters cubed. So this is just one version of the design that you might use. So I can hold 27 balloons in my 3 by 3 by 3 box, or my 90 by 90 by 90 box, right? So 3 balloons by 3 balloons by 3 balloons. You might have another configuration of your box. And that's okay, as long as you can fit all 27 balloons inside of your box.